Hi friends, welcome to our channel. So in this video, we are going to look at problem 3994, minimum adjacent swaps to partition array. So here the purpose is the following. First, we are going to demonstrate how to do problem transformation. And then I'm going to also practice a map function in Python. And finally, we want to demonstrate the procedure from longer code to compact code. So here, basically, we are given an integer array and two bounds, a and b. A is strictly less than b. So we want to partition the original array through neighboring swaps such that in the left, it's the elements strictly less than b. In the middle, so the elements are in between a and b, both sides are inclusive. And in the right, so we have elements strictly larger than b. So in other words, we form three consecutive groups, right? So here we want to find the minimum number of adjacent swaps required to make the nums good. So here is the return modulo this big prime number. So you can look at the three examples. The example 3 is very special because it's already in the order, right? You have 3, and you have 7, 5, and then you have 9. And the example 2 is the same 4 numbers, and it's you need to 5 inversions or swaps so that you can make it like this. So here, as in the hint, you can see that the specific element value is not essential. The essential thing is that we have 3 intervals, right? One is from -infinity to a. Another one is a to b, and the last one is b to positive infinity, right? So as long as this lives in those ones, so they are the same. In other words, you can identify this intervals as the element label or name, or you can name as in the hint. If it's less than 1, less than a, you name it as 0, and then in between, name it at 1, and above, you name it at 2, right? Same idea here. So once you have this, so the only thing you need to notice is to find the number of inversions, right? So this is rather straightforward. So basically, we have 3 elements only at each index. So you just need to count how many. For example, if you at index I, the number corresponding number is 1. You need to find how many 2's are to the left. Those are the inversions. But if for y you're corresponding to 0, so you need to find the number of 1's and 2's to the left. But for I corresponding to 2, because it's largest, so there's no inversion produced, right? So here we can first write a solution following this one and strictly follow this one, and we can practice the map function. So here I'm going to define a function or callable, right? So let's call it y. So we have a lower bound given by a, and the upper bound given by b, right? So if y is less than a, so we return say 0. Else if y is in between a and b, so we are going to return 1. Otherwise, so we're going to return 2, right? So this is the function, and then we can do a map. So I still use nums. So we map this function f, so to each element of the nums. So this gives us an iterable, so we can make it a list if we like, just to demonstrate. So you can print out this. So what you can get is, for example, this one, you get something like this. There's no inversion, right? There's inversion here, so 0, 1, so you get 1. Similarly here, so you get this one. So there's 5 inversions. So 1, there's 2 inside, producing 1, this one has a 2 to the left, produce another one. So here we have a 0. So all the 3 elements to the left is larger than the 0. Produces 3 inversions. In total is 5, right? So now once you have this, so we can use a dictionary to do this. So count the number of zeros, originally 0, and 1s is also 0, and 2 also 0. So those are the things to the left, right? So now we have a result. So counting the number of inversions. So basically for I in range length nums, so we want to check how many, for the current number, how many larger element to its left. So the current will be nums I, right? So then if current equals 0, so what do we do? So the result should be incremented by the summation. The summation will be the number of 1s to the left and the number of 2s to the left. Otherwise, if current equals 1, so we need to find the number of 2s to the left. Else that's 2, right? So we just do nothing. But in every case, so we need to update the count of the current, right? No matter it's 0, 1, 2. And then we consider the next round. So this way, so we can return the result modulo this big number, 10 to the power 9 plus 7. Let me first run the test. Yeah, it passes all the 3 cases. So now let's submit. Yeah, it passes all the cases, but looks like slow. The reason is that we don't need this to be material. We just need it to be virtual or on the fly. So what we can do is this. So we just need to count the number of zeros, 1s, and 2s to the left, right? So what we can do, we initialize a result variable, and then we have in zeros, in 1s, and 2s to be 0, 0, 0. But in this version, I'm using a dictionary to group all the informations. So now let's do the loop for y in nums. Actually, the index is also not essential, right? So now we just need to check if y is greater than b. So in this case, we regard it as a 2, right? So then nothing is larger than 2 in these 3 groups. So we just count this, increment this one, right? If it's less than or equal than b, but it's greater than or equal to a, so in this case, it corresponds to a 1. So the inversions we need to consider is the number of 1s, number of 2s to the left. So we need to do this and 2s. And afterwards, we need to add the number of 1s by 1. Another case is it's below a. So this will be 0. So we need to increment the number of 1s and the number of 2s to the left. And in this case, in zeros is incremented by 1, right? So, this is just a if-else block, but it's mimicking the first version. Then we just introduce 3 variables for this counting. So we just need to return the result modulo this big constant, big prime number. So now let's do a test. Yeah, so it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So to sum up, in this problem, the key point is to do the problem transformation, or you adapt to a pattern. And then we practice the map function, and also we demonstrate the procedure from a slightly longer code to compact code. The version we want is more, from the front to the end, right? So the sequential order. And the second version is that you realize the essence of the problem, and then you just write a very short code. Actually, this code can be even compact, but that's not our purpose in this video. So with that said, I guess that's it for the current video. Thank you for watching.